Hello all. So today we will cover one more concept, that is analysis of first order system. Yeah. So a first order system is represented as input, process and output, right? So this process will be only one RC. It will be having, this process will be having, or this plant will be having only one RC circuit. That's why it is called as first order system. So now according to this block, we'll have input as R of S and process as A divided by S plus A. Right? So this block is represented as A divided by S plus A. So if I take the gain, okay, that is output by input, so it will be A divided by S plus A, right? So if Rs is equal to 1 by S, if Rs is equal to 1 by S, then so we'll be having Rs as 1 by S multiplied by the gain of a system, that is A divided by S plus A, which can be solved further as, because I need to solve this equation whichever is been given. So how to solve this equation? This equation can be solved by a method wherein I need to take it as A dash by S, the first term as S, and the second term as B dash divided by the denominator, whichever is there, right? So B dash by S, S plus A. So what should be the value of A dash? The value of A dash will be 1. Okay, it has to be taken as 1. Right? So now, when such is the case, how to take B dash? How to take B dash? So B dash has to be minus, right, the one which is there with S, the one which is there with S. So for this, what we need to do, we have to take A as common here. So if I take A as common here, so what will be the answer? So it will be 1 divided by, okay, if I take A as common, so it will be 1 plus 1 by A into S into S. So this is what the equation becomes. This is what the equation becomes once when I take A common. So what should be B dash now? The B dash should be minus 1 by A, because the one which is there with S, I should take that one to substitute into B. So B dash is equal to what? Minus 1 by A. So if I substitute that, so the final answer will be what? C of S is equal to 1 by S minus 1 by S plus A. Even when I cross multiply this, if I cross multiply this, right, when I cross multiply this, I will be getting this same equation back, that is 1 by S into A divided by S plus A. Right? So this is how we have to solve this C of S equation. This is what we have to solve the output equation. Okay. Right? Yeah. So now if I want to know the inverse Laplace transform of the function which has been derived, right? So if I want to know that, so what should I do? I should apply the inverse Laplace transform. So how to apply? As we know that inverse Laplace transform has to be applied for each parameter, right? That is 1 by S into 1 by S plus A. For both, I should apply the inverse Laplace transform. Okay. So when I apply this, you can see here, I am applying inverse Laplace transform for both. So it is L inverse of 1 by S minus L inverse of 1 by S plus A. So we know that L inverse of 1 by S is a constant which is nothing but 1, right? L inverse of 1 divided by S plus A, right? So this is a standard formula. So if I do that, I will be getting the inverse Laplace transform as 1 minus e raised to minus at. So this is how we will get the inverse Laplace transform of S plane function. So when I do this, I need to draw the waveform. So to draw the waveform, we need to substitute, right? So how to draw the waveform? To draw the waveform, we have to substitute the value of t. We have to substitute the value of t in equation number 1. Okay, in equation number 1. So what it should be, initially we will take it as, because I want to substitute the value of t in this equation, so I will take this one as t is equal to 1 by a initially. So if I substitute this, I will be finding out that when t is equal to 0, when I put different values, when t is equal to 0, the output equation, that is this equation, the equation number 1 becomes what? Becomes what? Right, it becomes 0. When I substitute t is equal to 1 by a, the output equation, that is c of t, in our form it is c of t, it will be 0.63. When I substitute 1 by 2a, it will be 0.9. When I substitute infinity, it will be 1. Okay, so keeping this, if I plot it, okay, if I plot c of t with respect to time, I will be getting this waveform. The exponential waveform I will be getting. Right? So now here I need to derive some parameters. What are those parameters? The time which the response will take to rise from 0 to 10% is called as t1. Right? Similarly, if you can see that the output is rising from 0.1 to 90%, 0.1 to 90%, right? That is termed as t2. Right, and then afterwards it is again rising, and then it is remaining constant after 4 by e. Okay, based on this we will draw some of the parameters. What are those parameters? Those parameters are called as performance parameters. So time constant t, right? Time constant t is defined as 1 by e. Rise time tr. Okay, what is rise time? The time it has taken to rise from 10%, that is from t1, 10% to 90%. This area is referred to as the rise time. Okay, so what is rise time? The time taken by the curve to rise from 10% to 90%. This area is referred to as rise time. Okay, then settling time. What is settling time? Settling time is a one wherein the waveform gets settled. I mean, there won't be any variations. Normally it is 4 by e. After 4 by a, what will happen? After 4 by a, what will happen? This remains constant. Okay, so these are some of the parameters that have to be taken care when we are analyzing first order systems. Okay, thank you.